Hello, my name is Mark, and in this video I'm going to talk about aqueous ionic equilibrium, specifically how to calculate the mass of a salt to be added to a weak acid to form a buffer with a specific pH. The problem that I will be using is problem 17.3 from Khan Academy problems posted on Moodle. Let's go through this problem so you can see what you are being asked. What mass of sodium benzoate should we add to 150 milliliter of 0.15 molar of benzoic acid solution to obtain a buffer with a pH of 4.25? Assuming that the volume of the solution does not change when you add the salt. Let's write down the values that we are given in this problem. We are given the concentration of benzoic acid, which is equal to, and the same thing as Ma, which is equal to 0.15 molar. We're also given the volume of the benzoic acid, Va, which is equal to 150 milliliter, which is equal to 0.1500 liter. We're also given the pH of the buffer that we want to create to form, which is equal to 4.25. And we are asked to calculate the mass of sodium benzoate to be added to this volume of benzoic acid to form the buffer of 4.25. To find this mass, let's first of all write down the equation of this buffer that you want to form. And also after that, we write down the dissociation of sodium benzoate. Let's start by this buffer. We have C6H5COOH aqueous plus water, which gives the conjugate base aqueous plus hydronium ion aqueous. And this is the equation of the buffer. Let's also write down the dissociation of sodium benzoate. We have sodium benzoate, which dissociate into the conjugate base and sodium ion. And also we'll be using the Henderson equation. Henderson equation says that the pH of a buffer equals to pKa plus log of base, the concentration of the base over the concentration of the acid. In our problem, the base is the conjugate base, and then the acid is the benzoic acid. And looking at the values that we are given, we have the concentration of the acid, the volume, and the pH. And also looking at this Henderson equation, we have the pH, the acid, and we can easily calculate the base. And to do so, we first of all calculate the pKa. pKa, we have a Ka, which is equal to 6.15 times 10 to the power minus 5. And the pKa equals minus log of Ka, which is equal to minus log of 6.15 times 10 to the power minus 5, which is equal to 4.187. And then we have everything here to calculate the concentration of the base. If you get the concentration of the base, we can calculate the number of mole of the base by using the volume that we have here. Because they said we assume that the volume of the solution does not change when we add this sodium benzoate, which means we can calculate the number of mole of the base using this volume that we are given here. Let's first of all calculate the concentration of this base. We have 4.25, the pH, which is equal to pKa 4.187 plus log of concentration of the base over concentration of the acid. and this is equal to 4.25, which is equal to 4.187 plus log of the base minus log of the acid. We can isolate this term here. We have log of the base, which is equal to 4.25 minus 4.187 minus log of the acid. And this is the log of the acid is 0.1. The concentration of the acid is 0.15, and this is equal to minus 0.76. And we can calculate the concentration of the base by taking the power of 10 of this value, 10 to the power of minus 0.76, which gives 0.17 molar. We find the concentration of the base. We can calculate the number of mole of the base using the volume that we are given there. Number of mole of the conjugate base, which is equal to, and this is equal to 0.17 mole per liter. And then we have 0.17 mole per liter times 0.1500 liter. And we can easily get 2.6 times 10 to the power of minus 2 mole of this base. And looking at the dissociation equation of the sodium benzoate, we have 1 mole of sodium benzoate, which gives 1 mole of the conjugate base, which means we have the same number of mole of sodium benzoate, number of mole of C6H5COO now equal to 2.6 times 10 to the power minus 2 mole. And we can easily calculate the mass of the sodium benzoate by using the molar mass. The molar mass equal to 144.1 gram per mole. And the mass equal to 2.6 times 10 to the power minus 2 mole times 144.1 gram per mole. And this is equal to 3.7 gram. And this is the mass of sodium benzoate that we need to add to this volume of benzoic acid solution to obtain a buffer of 4.25. We can see that to form this buffer, we need exactly 3.7 gram of sodium benzoate to be added to 150 milliliter of 0.15 molar of benzoic acid. Thank you.